At a normal fasting level, all the glucose in your bloodstream adds up to roughly 1 teaspoon. Yet, if the system controlling that teaspoon begins to fail, the consequences can eventually reach your eyes, kidneys, nerves, heart, and brain. So how can something so small become so dangerous? After you eat, much of the carbohydrate in food is broken down into glucose. It crosses the intestinal wall and enters the bloodstream, becoming fuel for cells throughout the body. Glucose is not a poison. Your brain and muscles depend on it. The danger begins when the body can no longer control where glucose goes or how long it remains in the blood. Behind the stomach sits the pancreas. Inside it are tiny clusters called islets, containing beta cells that monitor rising glucose. When they detect it, they release insulin. Insulin is a biochemical signal. In muscle and fat cells, it moves glucose transporters called GLUT4 towards the surface, allowing glucose to leave the blood and enter the cell. In the liver, insulin reduces glucose production and encourages storage. But diabetes is not one single failure. In type 1 diabetes, the immune system attacks insulin-producing beta cells. The body then makes little or no insulin, so insulin treatment is essential for survival. Type 2 diabetes is different. Especially early on, insulin may still be present, sometimes in large amounts, but muscle, liver, and fat cells respond less effectively. This is insulin resistance. At first, the pancreas compensates by releasing more insulin. Blood glucose may remain near normal while the system works harder in the background, but resistance can worsen, and beta cells may gradually lose function. Eventually, insulin supply can no longer meet demand, and blood glucose rises. The pancreas has not simply become tired. Type 2 diabetes combines insulin resistance with changing beta cell function. Visceral fat can contribute to this process. This is fat stored deep around internal organs, not simply beneath the skin. Enlarged visceral fat tissue can release fatty acids and inflammatory signals that interfere with insulin signaling, but it is not the only cause. Genetics, age, activity, sleep, medicines, and other factors can affect risk. This is biology, not a simple failure of willpower, and high blood glucose does more than circulate harmlessly. Over time, persistent hyperglycaemia can promote oxidative stress, inflammation, and advanced glycation end products. These processes can damage the endothelium, the delicate inner lining of blood vessels. Small vessels supplying the retina, kidneys, and nerves are especially vulnerable, while damage to larger arteries increases cardiovascular risk. This is why diabetes can affect vision, kidney function, sensation, wound healing, the heart, and the brain. These complications are serious, but reducing long-term glucose exposure and other risk factors can lower the danger. Now, for the surprising part, working muscle has another route for glucose. When muscle fibers contract, they can move GLUT4 transporters to the cell surface through pathways that are partly independent of insulin. The muscle can then pull more glucose from the blood for energy. Exercise can also improve insulin sensitivity afterwards. But exercise never replaces insulin treatment in type 1 diabetes. Muscular contraction simply gives the body an additional way to handle glucose. So can type 2 diabetes be cured? The medically accurate word is remission. An international consensus defines remission as an HbA1c below the diagnostic threshold for diabetes for at least 3 months without usual glucose-lowering medication. Significant weight loss can, in some people, especially earlier in the disease, reduce excess fat in the liver and pancreas and allow glucose control to improve. In the UK DIRECT trial, 46% of participants in the intervention group reached remission after 1 year, and 36% remained in remission after 2 years. But remission is not guaranteed or necessarily permanent. Blood glucose can rise again, so continued monitoring still matters. The real story of diabetes is not that sugar is simply toxic. Glucose is essential. The problem is a control system losing precision. Insulin sends the signal, tissues stop listening, beta cells struggle to keep pace, and excess glucose remains where it can cause harm. And sometimes, by changing the conditions around that system, the body can regain far more control than most people realize.